Next we'll discuss bitwise operators. Now in C, it is possible to perform operations on a bit level. That means we can perform operations on individual bits instead of performing operations with 8 bits or bytes at a time, as we had done using logical operators earlier. Now, what are the different types of bitwise operators, or what are the bitwise operators? So let me highlight them for you. So these are the bitwise operators. The bitwise negation is a unary operator. That means it has only one operand, and the rest are binary operators. They have two operands. This is the bitwise AND or exclusive OR. This is the right shift and the left shift. So the bitwise AND and OR operations are similar to the AND or OR operations when we had discussed the logical operators. That is, they are similar to logical AND and logical OR operations. The bitwise exclusive OR operation needs to be discussed in small detail. To do so, let's go to our let's revisit the truth table for the logical OR operation, which I have already discussed earlier. Here, what I do is I would add another column for the logical exclusive OR, not logical exclusive OR. This is the bitwise exclusive OR. Keep in mind, there aren't any logical exclusive OR operators. So this bitwise exclusive OR, what it does is, when any one of the inputs is 1, so if we take this combination or this combination, we see only one of the inputs is 1, then only the output would be 1. So there is some sort of exclusivity here, and in all other cases the output would be 0. 1 signifies true state and 0 signifies false state. So this is the output in the truth table for the exclusive OR. So let me write over here OR or XOR. So this is OR, this is XOR. So keeping this in mind, we can try to understand what happens when we use a bitwise OR operation, a bitwise exclusive OR operation rather. Now, apart from the AND OR, bitwise NOT, and the bitwise exclusive OR operators, we also have two other bitwise operators called the right shift and the left shift. So to understand these operators, we need to take the help of a program. So as before, we have already a program at our disposal. I have already written this out. So let's see what goes on in this program. Here, x is equal to 2 and y is equal to 7 are two unsigned character variables which have been initialized with values 2 and 7 respectively. That means x is in binary, since they are of unsigned card type. That means they correspond to 1 byte, and 1 byte means 8 bits. To express it, so expressing the decimal number 2 with as an 8-bit binary number, we should write it as 0000, 0010, and y as 0000, 0, 1, 1, 1. Fine. Now, what we would like to do is we want to find, or rather print, the value of the result of the exclusive OR operation on x and y. So since if you remember, I said in bitwise operations, the operations are carried out on the bit level. What that means is each pair of individual bits, 0 of x and 1 of y, they are exclusively odd, and the result is, we can write the result just beneath the pair. So 0 and 1 is 1, 1 and 1 is 0, 0 and 1 is again 1, and all these are 0. If only one of the inputs is 1, then only the output is 1, otherwise the output is 0. So this translates to decimal 5. So if we can put a 10 over here to signify that the result is 5 in decimal. We can execute the program and see the result for ourselves. Now, what we can do is, before executing the program, we would see for ourselves or try to understand another of the bitwise operations, that is left shift. So this is the one, this is the left shift operation, and the syntax is x less than symbol 2. Now instead of 2, you could have any number. What this signifies is, when we write x less than symbol say n, that means this value of x, that means the bit pattern in x, is shifted to the left, and it is shifted bit by bit, one bit at a time. But how many times? N times. So if it is n is equal to 2, that means there would be shifting to the left 2 times. And what happens actually is, when we shift to the left, the most significant bits are discarded and zeros are appended after the least significant bits. I mean, zeros are appended to the right. So what happens is, when you perform this operation, this pattern is shifted so that you would have, so this is the pattern. If you shift this to the right, this is discarded and a 0 is appended over here. So if you write the 8 bits again, it would be 0, 0, 0, 0, 0, 0, 1, 0. Am I correct? 0, 0, 0, 0, and then I'm not correct, sorry. It is 0, 1, 0, 0. So this is the result after shifting the bit pattern to the left once. Now since n is equal to 2 over here, we have to shift it again to the left. So this is discarded, a 0 is appended, and if we write it again in this form, so this is what we get finally as the result. Now this is nothing but 8 in decimal. So this is the result of the left shift operation. One important point to note is, when we left shift a bit pattern by n number of times, it effectively means multiplying x, the number which is being shifted, by 2 to the power n. So in this case, since n is equal to 2, the final result should be equal to x multiplied by 2 to the power 2, that is x multiplied by 4. So since we started out with x is equal to 2, that means 2 into 4 is 8, so we should be obtaining the value of 8, and that is what we have obtained. So that means a left shift operation by n number of times effectively means multiplying the number which is being shifted by 2 to the power n. Similarly, we could play around and test the right shift operation and also the other bitwise operators. Okay, now we'll be discussing the ternary operator. Now let me highlight it for you. Note the spelling T-E-R-N-A-R-Y, ternary. This operator constitutes the symbols question mark and colon side by side, question mark followed by the colon. Now why is it called the ternary operator? Because it operates on 3 operands. There are 3 operands for the ternary operator. You must remember that for unary operator you have only 1 operand, for binary operator you have 2 operands, and therefore for ternary operator you have 3 operands. Now the form of the ternary operation is this. It constitutes of expression 1 followed by the question mark symbol, followed by expression 2, followed by colon, followed by expression 3. Now the whole operation is again an expression. This results in an expression, and the value of the expression can be assigned to another variable. Now what is expression 1? It signifies a condition. Now if the condition, test condition you might call it, if the result of the condition is true, that means in C the resultant value is non-zero, then expression 2 is evaluated and its value is returned as the value of the whole expression, whole ternary expression. On the other hand, if the result of the test condition is 0, that translates to the condition being false, then what happens? Expression 3 is evaluated and its value is returned as the value of the whole expression, which can then be assigned to a variable. To understand this fully, as before, we need to take the help of a C program. Now I have already written down the program for your benefit so that I can save on time. So have a look at this program. Now I'll be taking up different examples of ternary operations one after another. The first one comprises of this operation. As you can see, let me highlight it again for you. So this is the first condition or the first expression, which is a condition expression related to a testing of a condition. So this is testing whether the variable x, an integer variable which has been initialized with the value 2, whether this x variable is in fact equal to 2. Now if this test condition is satisfied, that is the result is yes or true, then what happens? The expression following the question mark is evaluated and its value is returned as the value of the whole expression and printed over here. On the other hand, if the result of the test condition is false, then what happens? The expression following the colon symbol is evaluated and its value is returned as the value of the whole expression and is printed in this place. So in this case, since obviously x in fact is equal to 2, this would result as in true condition. This would be true, the result would be true, and therefore this expression will be evaluated, which results in 2 being incremented by 1 and assigned to 3. So this basically would result the value of 3 being returned as the value of this expression and printed over here. So let us just check whether this in fact happens or not. So let's compile and run. Let's shift this. Okay, the value is 3. So just as we expected. Now what happens if we change the initial value of x to say 5 and run the program again, compile and run the program again? As you can see, the value of x is now 4. Why? Because this condition would be tested and return a false, because x is obviously not equal to 2, is equal to 5. So instead of this expression being evaluated, the one next to it after the colon symbol, this would be evaluated, and the value of x, which was initially 5, would be decremented by 1, and the new value of x would be 4, and that value would be returned as the value of the whole expression, symbolizing the ternary operation, and then get printed over here. So we see the value of 4 being printed as expected. So this was an example of a ternary operation. Now there are different finer points that we can understand by taking a few more examples of ternary operations. Now in the next examples, you have, instead of using an expression for the test condition, I've just written x. Now what does simply writing x signify? Now value of x is 5. This value is non-zero. A non-zero value of x symbolizes that the Boolean value is basically true. So the result of the test condition is true, since the value of x is positive. Any positive value over here would translate to the test condition being true, and this would result in the expression, the one following the question mark, to be evaluated and returned. So the value of x being 5 is incremented, and that would be returned as the value of the whole expression and printed over here. So let us test this. We need to compile and execute it again. Yeah, it is 6, just as we expected. So let's close it, and now we move over to another example. So let's see. In the next example, you see the test condition is itself an expression. So it's x is equal to x minus 1. That means the value of x initially was 5, that is being decremented, it becomes 4, and then the condition for true and false is tested. Now 4 is non-zero, so that translates to the condition being true, and so again this expression will be evaluated and the value returned. So as before, we should expect, what should we expect, since x had already been decremented by 1, so now it is again incremented by 1, so we should expect 5 to be returned as a value of the whole ternary expression and then printed in this place. So we again compile and execute it and see for ourselves. Yeah, the value is 5 as expected. Now what we do, we change the value of x to say 1. Now what happens? Now you see over here in this expression, the value of x initially was 1, it gets decremented and it becomes 0. So the result of the test condition is 0, which translates to it being false. The Boolean value is false. So if it is false, which expression would be evaluated? This or this? The answer is this, the expression following the colon. So the value of x, which was initially 1, is first decremented, becomes 0, the condition becomes false, then this is evaluated. Now the value of x is now 0, it is decremented by 1 again, and the new value of x is minus 1. So this new value of x, which is minus 1, is returned as the value of the whole ternary expression and printed over here. So let's check it again. We compile and execute it. Yeah, it's minus 1, just as we expected. So far so good. Now we take up the last example. Here you see, this is a very compact expression involving a ternary operator. Here, in the place of the test condition, I have put 0. In the place of the expressions, I have put 3 and 2 respectively, after the question mark and the colon respectively. Now, as you can see, instead of having variables or expressions in the whole ternary expression, we can simply have numbers. Now, having 0 over here implies the test condition to be false. That means the Boolean value or the Boolean result from the test condition to be false. That would mean that the expression after the colon would be evaluated and the value returned. But since we don't have an expression over here, we have the value itself. So very simply, this value would be returned as the value of the whole ternary expression and printed over here. So what we expect to see is nothing but 2. Let's see for ourselves. So again we compile and run. Let's move it over here. See, the answer is 2. This one, just as we had expected. So this ends our discussion on ternary operators. Finally, we'll talk of a few special operators in C. Now these operators belong to the last category in the list of operators in C programming language that we had presented at the very outset. Now what are the special operators that we would be discussing here? Let me write them out for you. The first is the size of operator, SIZEOF. Then is the address of memory operator, symbolized by the ampersand symbol. Then we have the dereferencing operator associated with pointers, symbolized by the asterisk symbol. Now this must not be confused with the multiplication operator. And finally, the last special operator that we would be discussing is the cast operator. So these are the 4 operators which we will try to discuss and rather understand, taking help from this program which I have already written for you. So let us take them up one by one. The first is the size of operator. Now we have used the size of operator in this program over here and over here. The size of operator basically returns the size of its operand. Now in this case the operand is car. Now the car data type corresponds to 1 byte of memory or 8 bits. So the size of operator when operating on the car data type would return its size in bytes, that is 1. So we would expect to see 1 over here in this place. Similarly, when size of operator is operated on the int data type, now int data type corresponds to 4 bytes, usually 4 bytes or 32 bits. So the size in bytes is 4. So we would expect 4 to be printed in this place. Next we move on to the address of memory operator, the ampersand symbol. So in our program we have used this operator over here and over here. What does ampersand of x do? Now see, x is a variable which has been declared to belong to the card data type over here. Whenever this is executed, space in memory corresponding to 1 byte is reserved. Now the address of that memory space or memory location is returned when we invoke ampersand x, and that is printed over here. As you can see, the format specifier used is %p, because when we want to print addresses, the addresses are hexadecimal addresses, and it's a convention to use the format specifier %p. Similarly, when we use the ampersand operator on I, now I is a variable which has been declared to belong to the int data type over here. When this is executed, the moment this is executed, usually 4 bytes or 32 bits of memory space is reserved. The base address of this memory space is returned when we invoke ampersand I, and that value is printed in this place. So we have discussed the address of memory operator, and we move on to the next operator, which is the dereferencing operator associated with pointers. So where have we used this operator? Over here and over here. So notice P1 and P2, what are they? Now P1 has been declared over here for the first time, and P2 has been declared over here, not for the first time. It has been declare operators only, declare variables only one. Now P1 is a pointer variable. Now a pointer variable is one which itself contains an address so that it can point to another variable. Now the data type of the variable it is pointing to, that data type would also have to be mentioned in front of the pointer variable when it is declared. So in this case, P1 is to point to a character variable. That's why we write car star P1. When we write car star P1, what it means is P1 is a pointer variable which points to another variable of card data type. But P1 itself should hold the address of that variable. So how do we make sure of that? Look over here. Address of x is assigned to P1. Now what is x? Maybe I should remove this. Yeah. So x has been initialized with the small case character a, ASCII character small case a. Now the address of this variable x in memory, that address is assigned to P1. That means that variable, that value, that address value is moved to P1. Now when we write star P1, what happens is that the value of the car variable x, which happens to be a, small case a, that value is again referenced. That value is again obtained by using star P1, and that value is printed over here using the format specifier %c. This is called dereferencing. We could have easily printed the value of x over here. Instead of writing star P1, we could have written x, and that would have given us the same value. But here we are referencing x in a roundabout way through the use of the pointer P1, which has the address of x. The same thing can be done with P2, the pointer variable P2, which has been declared over here. That means P2 is a pointer variable which points to another variable which is of integer type. So this is how you declare a pointer variable which points to an integer variable. Now, when we use this statement, P2 is equal to ampersand I, what happens is let me just remove this. Yeah, as you can see, I had been initialized with this integer value. So the address of I in memory space, that is the base address of I, is assigned to P2, and then the value of I, which is nothing but this, is again referenced in a roundabout way by writing star P2. That means when we write star P2, the value of the variable that P2 points to, which in this case is nothing but I. Why? Because P2 contains the address of I. That value of I is referenced in a roundabout way, and this value is printed over here. Now, since this value is an integer, we use the format specifier %d. We again, as before, could have simply written over here I and got the same value printed, but we are using star P2 to show that this type of dereferencing using the pointer variable, dereferencing variable that we have used over here, star P2 can lead us to the same value of I, this one, which we would have obtained by writing simply I over here. So this is how the dereferencing operator associated with pointers can be made use of to obtain the values of the variables they are pointing to. So finally, we are left with the last special operator, which is the cast operator. Now this is a very simple operator. Suppose we have declared a variable pi to be of float type and initialized it with the real number 3.141593. In fact, instead of writing 3, we should write 3.141593f. That would signify it's a float constant. Now, where have we used the cast operator? Let me highlight this. Yeah. So as you can see here, within parentheses I have written int and then followed it with pi. So here int is the cast operator. Now this int is a data type. This int within parentheses is an operator. This is a unary operator, also known as the cast operator, which operates on a single operand, which happens to be pi in this case. Now pi is declared as a float type variable and initialized to a real value. When we invoke int on it, that means when we operate int on the pi operator, what it does is it converts it into an integer. How? Basically it truncates this value. It just omits or discards the fractional values, everything that comes after the decimal point, and we are left with only the integer part, that means 3. So casting basically discards the fractional part and retains the integer part when we use casting using the int cast operator. We could have other cast operators as well. This you can check with your textbooks or online tutorials, and maybe you can write simple programs to test those cast operators by yourself. Okay students, so we have finished discussing all the different categories of operators. I may have missed one or two operators which you might feel are important. In that case, I would ask you to learn about them by yourself, or you can point them out to me using your Google Classroom so that we can have a discussion on them as well later. Any discussion on operators in C, or for that matter in any programming language, would be incomplete without mention of what is known as operator precedence. Now, what is this operator precedence? To understand this, we write an expression, say so when we want to evaluate this expression in C, either the addition operator could be evaluated first and then the result could be multiplied with 2, or the multiplication would happen first and the result would be added to 3. Now, which of this actually happens when we evaluate this expression in C language? The answer would depend on what is known as operator precedence. More specifically, it would depend on whether a multiplication operator has higher precedence over the addition operator or vice versa. Now in C, we need to know that multiplication operator indeed has higher precedence over the addition operator. So the evaluation would be done in this form. That means the multiplication operation would occur first and then the result would be added to 3. Now let us take up another expression. Say 4 multiplied by 10 modulo 4. Now all of you must be knowing what a modulo operator is. It returns the remainder of an integer division. Now here 10 and 4 are two integers, so 10 modulo 4 would return 2. Now here you have two operators, multiplication operator and the modulo operator. Now when this expression needs to be evaluated using C, how does C go about doing it? Does it evaluate this expression by multiplying 4 into 10 first and then performing the modulo operation with 4 with the result? Or does C evaluate the expression by evaluating 10 modulo 4 first and then multiplying 4 with the result? So again we have to take recourse to precedence, but the problem is the precedence of multiplication and the modulo operator is the same as is for the division operator. So multiplication, division, modulo operator all have same precedence. So in that case what happens is we have to look for another property which is known as associativity. So let's write it down. Associativity. Now what associative means is when two or more operators have the same precedence, then they either have left to right associativity or right to left associativity. That means if the bunch of operators having the same precedence have left to right associativity, then the operator lying on the left would be evaluated first. I mean the operation involving the operator lying to the left would be evaluated first, and so forth. So in that case, when we want to evaluate this expression, since multiplication and modulo have the same precedence but the associativity is left to right, that means the multiplication operation would occur first since it is to the left, this operator is to the left, and then the result would be modulo operated with 4. So this is how the evaluation would occur. To test this, we might as well take the help of a program, simple program, where you see I have printed the values of 4 into 10 modulo 4 as well as 10 into 4 modulo 10 modulo 4 into 4. So if you execute this program, so let's do it, we compile and run this program and see for ourselves that the result is different. So when we want to evaluate this expression, 4 multiplied by 10 modulo 4, as we had started out with, we are interested with this expression, then the result would be 0. That can only happen if the expression is evaluated in this order. That means the multiplication occurs first and then the modulo operation. But one thing it's very important to note or remember is that associativity property only comes into the picture when the operators have the same precedence. Otherwise, there is no role for associativity. The precedence takes care of the order of evaluation in an expression. Now there are many other operators, so you need to have an idea of their precedence and associativity rules. They can be obtained in chart form or in tables. You have to browse the web for that or take a course to any online tutorial or textbooks or whatever. If you have any difficulty, then of course you can contact me. So students, this brings us to the end of our audiovisual lecture on operators in the C programming language. I could have missed one or two important operators in this discussion. If you happen to come across one or two such operators which I may have missed, please let me know through your Google Classroom or by other means. Thank you. Till we meet in our next audiovisual tutorial.